Okay.
So, okay. Good morning to everyone. Research project, which is a 5 years long project coordinated by Fertiliser, in which 11 entities that you can see there represented are developing and validating different technologies that involve the use and transformation of bio-based materials in different sources for their incorporation in the fertilizer industry. So next slide, please. Right. The main outcomes and goals that we expect to reach at the end of the project are those that are presented. Firstly, and this is very important, the development of innovative logistic models to facilitate this implementation of the bio-waste into the fertilizer value chain. We are finding, because we are now working we have finished the second year of the project, so we are almost in the middle of the project. We have found and we are trying to solve many bottlenecks and hurdles that we face as fertilizer industry to implement this kind of material. So we are finding solutions to overcome them. Secondly, we are demonstrating new technologies at demo scale. For instance, nutrient extraction from different sources, especially ashes and phosphorus mainly. And also the new technologies for fertilizer coatings with different kind of bio-based additives that we are developing. For instance, new biostimulants, microbial and non-microbial, biopolymers, and all of them will lead to the creation of new families of mineral and organomineral bio-based fertilizers. Finally, and we have already started, we are starting the validation of all these fertilizers. Now they are prototypes, but we expect to have all of them more proof in these agronomic fit trials in this project in 5 different locations in Europe, in different areas and climates, and we will use satellite images technologies to monitor well all the trials, and we will compare these technologies to the usual ways of measure the efficiency of the fertilizers. You can see different pictures on the right of the slide. Some bio-based materials, biostimulants, biopolymers, fermentation processes, greenhouse trials, and fertilizer prototypes that we have already developed. Finally, next slide, please. Okay, nice. You can see here, this is the main scheme of the project. This is the goal gathering in one site, in which different bio-based materials, as I have already mentioned, are fed in the fertilizer industry, mixed with the usual raw materials, and also are different kind of materials, those whose nutrients are not available for plants, because we work with availability and solubility of nutrients, especially phosphorus in this case. So we will mix all the materials, so the bio-based materials and the raw materials in the fertilizer industry, in the demo sites, I mean, that will be located in Fertiberia. And then once the bio-based materials is incorporated, we will coat them with this additive that I have already mentioned, biostimulants and biopolymers, in order to create different tailor-made fertilizers that we expect to produce at the end of the project. And this is all from my side. Thank you.
Thank you, Maria, for your presentation. Is there any questions directly to this presentation? We can take 1 or 2 questions. If there is not any question at this moment, I could make one that how do you evaluate the quality of these fertilizers? Is it mainly agronomic efficiency, or is it like how safe these are? So what are the other parameters you are studying on this project?
Yes, we of course evaluate the agronomic efficiency of them, but also we completely analyze and monitor the bio-based materials that we are working with. We have defined and we have developed in the project, let's say, a screening criteria in which we can guess at the beginning if the bio-based material is good or not for us. The thing is that from our company, we don't sell any nutrient that is not available for plants or water soluble. So for us, the main thing is to use bio-based materials whose nutrients are available for plants. For us, availability means one of the parameters of the regulation. For us, availability means soluble in neutral ammonium citrate in the terms of phosphate. So then the bio-based material with phosphorus, for instance, must have very high solubility in this extractant, 100% almost. This is one of the things, but the other thing are, of course, the one mentioned by the regulation and Asturias document, which we are following, of course, this criteria. And it's a very complex thing, and there are many factors, and every material must be evaluated globally. So, but this is more or less the...
Yes. Thank you. I think that we have to proceed in order to have all the presentations. So
sorry.
Well, I just informed that you have a 3-minute time limit for most of your presentation, and in some of you have only 2 minutes. So let's try to stick with this. Yes. So the next presentation is Anne-Kristin Løs from Norwegian Centre for Organic Agriculture. Floor is yours, Anne-Kristin.
Yeah, thank you very much. So I hope you see the screen and that you can hear me. Can you hear me well?
Yes, yeah, perfectly.
Okay. Okay, so thanks a lot for this opportunity to present a combined project. Because we have funding from 2 projects. First, we started out with a locally funded project from the county of Møre and Romsdal, which is the county in Norway where Nordsjø is located on the northwestern coast. So nearby the coast and the fish residues. And then we also have funding from Horizon 2020 project Organic Plus, which is about phasing out contentious inputs from organic agriculture. And animal-derived fertilizers, such as dried poultry manure from conventional farming, is one of the fertilizers we want to see if we can find some alternatives for. So that is why we at Nordsjø work with marine-derived fertilizers. So today a little bit about fish, because that contains a lot of phosphorus. So as you all know, Norway has a very long coastline and is a big country when it comes to fish. We produce a lot of fish and we capture a lot of fish, and we produce a lot of salty fish and dried fish, which we export, and that creates a lot of waste from lean fish or white fish, such as cod and saithe. So we have made estimates that about close to 4,000 tons of phosphorus could be available in such residual materials each year. And that is about 25% of the total Norwegian phosphorus application in mineral and animal fertilizers. So it is a significant amount. But we have to be careful, because there is nobody want to invest a lot of money to make fertilizers. I think all industry actors want to make some pet food or a pharmaceutical product which they can earn a lot of money. So the final slide. If you can take the next slide. Yeah, so that is just to show you some of the experiments we have been doing. So that was the picture is a field experiment with dry grass that we conducted last year. The table shows the composition of some of the chemical composition of the fish bones, because the main ingredient in these residues, you maybe already saw all the backbones of the fish. They are grinded, conserved with formic acid, and then you can dry them and put them in the field, and they have a very rapid growth effect due to the nitrogen, but they also contain a lot of phosphorus. So then it's the question, how available is that phosphorus and so on. So, but so far we mainly demonstrated the nice fertilizer effect of these fish bones, and it is a significant resource of phosphorus that we should definitely treat better, because today it's currently often wasted, just like going to biogas or maybe better, more often incinerated as a waste. So so actually that is what I like to say, because I think 3 minutes have likely already passed. Yeah.
Yes, 3 minutes goes actually quite fast.
Yeah.
So is there questions for Anne-Christine?
I see Karin has raised her hand.
Yes, thank you very much. Thanks a lot for the presentation. I just wondered to clarify this 120,000 tons per year that you estimated. Do you mean that all that is fish bones? Or how did I misunderstand maybe the figures?
Yeah, it would be a mix of intestines and heads and skin and bones, and so that means that heads and bones, or heads and backbones, would comprise a very large proportion of that 120,000.
Okay, yeah, okay. And some of that goes to biogas, as I know. Yeah, I've been working a little bit with those figures, so I just wanted to clarify. Thanks a lot. Very, very interesting concept.
I was also wondering that is this kind of a fertilizers already sold in Norway, or is it already used by the farmers?
It is actually permitted for use also in organic farming, because it is considered as a type of fish product. But it is not yet developed as a commercial product which you can buy.
Okay, thank you. Okay, thanks, Anne-Christine. And I think that we have to go forward. And the next presentation is from Francisco Gabriel Asian Fernandez. Sorry if not pronouncing it quite rightly, from University of Almeria, and presenting Sabana project. Please go ahead.
Thank you. My name is Gabriel Acien, as you already mentioned. I am Professor of Chemical Engineering at the University of Almeria and coordinator of Sabana project. This project is devoted to the recovery of nutrients from wastewaters, sewage or manure, using microalgae to transform it into biostimulants and aquafeed also. Then in this project, we have a relevant consortia, as Veronesi is an Italian company producing feed and aquafeed. Aqualia is a relevant company in the sector of wastewater treatment, and Biohorizon is a SME company in Spain already producing biostimulant for agriculture based on algae. I mean that we already have the stakeholders, the final users of the products as part of the consortia. Please, next slide. The aim of the project is to demonstrate, because this is an innovation action, to demonstrate the feasibility of this type of processes in terms of large-scale production, because we already built 5-hectare facilities producing more than 100 tons of microalgae biomass per year. Sustainable production, because we are reducing the energy consumption and recovery up to 10 tons of nitrogen per hectare and per year, and 2 tons of phosphorus per hectare and per year from the residual, from the waste. And also we already demonstrate the products, because we are already evaluating the products in the real field with the farmers and the aquaculture companies. Please, next slide. This is only a picture about the technologies that we are already developing and evaluating as part of the project. I want to emphasize that we are developing complete industrial facilities. We are producing currently tons of materials to be evaluated in the different applications. And concerning agriculture, this is the topic of this session, we already demonstrate that the products that we are producing are not mainly fertilizer. That means that we are not providing nitrogen and phosphorus, but we are providing more advantage for the plants, because we are enlarging the root system of the plants. We are improving the health of the plants, and that means that the plants finally produce better products and high quality products. Including, we demonstrate that the benefits are including a step forward, because the plants are more resistant to pathogens and some disease, especially related with fungi. And in terms of aquaculture, it is very important also to explain here that we are providing materials to replace some other raw material like cereal, fish oil, fish meal. And we already demonstrate that the incorporation of algae biomass, very cheap, produced using these technologies, as part of the aquafeed, also improve the quality and the health of the fish, and I mean in the final quality of the fillet that the consumers finally eat. And that's all. Of course, I will be pleasure to respond whatever question. Thank you.
Thank you. You were exactly on 3 minutes. So any question? I was just wondering regarding these.
We are using currently sewage, but also we can use manure, digestate, whatever residual containing nitrogen and phosphorus, including the 2 plants already being in operation by Aqualia, are based on the recycling of nutrients from sewage. Yes, we have all the permission to use the biostimulants that we are already producing in agriculture, also in aquaculture. But in aquaculture, we must accomplish the HPPC criteria. I mean, the safety containing microbiological toxicity, heavy metal presence, and whatever, but we already accomplished it. The barriers to expand this technology are mainly related with the unknown from the regulators about microalgae facilities, not about the products. The products are accepted in the market, but not the installation of new facilities producing microalgae, because sometimes it is difficult to say if this is aquaculture, this is agriculture, or which type of technologies are related. Yes, for aquaculture, we are able to demonstrate that there is not pathogens, there is no E. coli, Salmonella, Clostridium. We already measure it, and including during the processing of the biomass to produce the final aquafeed, we reduce in 2 orders of magnitude. We are able to remove completely the presence of these pathogens. The carbon footprint is really low because we are able to recover the carbon from the wastewater, not only the nitrogen and phosphorus. I mean that we are saving CO2 emissions to the atmosphere. Also nitrogen oxide emissions and whatever. And the energy consumption is really very low, including we are developing a self-sustainable process in terms of photovoltaic, using photovoltaic units to provide the energy required.
Okay, I think that we can take the rest of the questions at the end of this session if we still have time. So thank you for your very good presentation. And next is Eeva Brod from Norwegian Institute of Bioeconomy Research.
Hi, can you hear me well?
Yes.
Thank you, Kari. So my name is Eeva Brod. I'm working as a researcher at NIBIO in Norway, the Norwegian Institute of Bioeconomy Research. And I would like to give going project Ketsløpsis. Next slide, please. So Ketsløpsis is one of several strategic institute programs at NIBIO, which are funded by the Norwegian Research Council. This project started in 2017 and is now in its final year. The total budget has been around 17 million Norwegian kroner, and around 13 researchers at NIBIO are actively involved in this project. The overall aim of the project is to contribute to the future bioeconomy by providing new knowledge on sustainable use of waste resources as fertilizer in agriculture. A very broad aim, but we focus on 4 particular challenges related to recycling. 1, concentrating nutrients from liquid waste streams. 2, unknown fertilization effects of organic waste resources, particularly nitrogen and phosphorus. 3, microplastics and other undesirable components. And 4, socioeconomic barriers. So to dive a little bit into the content of the project, I wanted to give you a short abstract of our activities on phosphorus. Thank you for the next slide. And specifically on phosphorus effects of fish sludge and manure solids. So fish sludge are feed residues and excrements of farmed fish. We don't talk about the slaughterhouse waste as compared to Anne-Christine, but about the manure of fish. Fish sludge is a waste product of very large importance for Norway, because Norway is the world's largest producer of farmed salmonids. I even have a sample of fish sludge here. We compared in this project the phosphorus effects of several fish sludge products with solid manure products in a field experiment, in a 2-year pot experiment, and through sequential fractionation. And we found that the phosphorus quality in fish sludge is in general much lower as compared to manure solids. And this is because phosphorus in fish sludge is mainly present as stable calcium phosphates. We also looked into phosphorus quality of biochar based on fish sludge and swine manure, and the phosphorus quality in both products was very poor. So we found that efforts are needed to optimize the phosphorus effect of fish sludge if this waste is to be transformed from a waste into a valuable fertilizer product. This is what I wanted to share with you in 3 minutes. Please check out our website for more information or send me an email. And of course, I'm open for questions as well. Thank you for your attention.
Thank you, Eeva. Any questions?
Maybe I can take one. Thank you, Eeva, for very honest presentation by showing also the negative results. But do you have any alternative of what could be the use of this if it's not such available for fertilizer?
Well, based on these results, we look into how to treat the waste in different ways to make the phosphorus more available. I still think it's the best solution to look into use as fertilizer, because agriculture is using most of the phosphorus that is mined at the moment. But yeah, we have to look into how to make it more available to really recycle it.
Mm-hmm. Thank you.
Thank you, Eeva, for very nice presentation. And the next, we have Lars Taumann Jensen from University of Copenhagen. And unfortunately, you have only 2 minutes. I have been informed.
I'll try to be quick, Kai, and I only have one slide. So you can see I overfilled the slide with a lot of information. I'll tell you about a project within the same area as everybody else here. But the project is different in the sense that it's a Marie Curie training program. So it's an innovative training network. That's what ITN stands for, with the title New and Biobased Cycling. So I think it's clear to all of you what the project is about. It's basically about taking waste streams, whether they are agricultural, urban, or industrial, and converting them into valuable fertilizers. So we are 10 beneficiaries, so 9 academic institutions throughout Europe and 1 private company as beneficiaries, and then 6 partner organizations, mainly private companies. So we started in 2020 with this project, with the aim to train the next generation of scientists for the circular economy, because I think that's one of the issues that we realize, that with this massive focus and the huge number of projects also listed by the Phosphorus platform, it's clear that we need more scientists who are to this field. So therefore, we want to train this next generation of scientists for developing fertilizers, but also to know that we need to have knowledge on the soil utilization, the plant utilization, and the environmental impacts, but also the market opportunities within this. And with doing this, being able to substitute fossil resources. So we have 5 work packages in which scientists are now working, so on processing, on application, and on impacts. And in spite of COVID-19, we have been able to recruit very talented people from all around the world. Nice photos of them down here, that have just started their research projects on creating new bio-based fertilizers. If you want to know more about the progress of their studies and their results, follow us on social media and our web address here.
Thank you, Lars. Any questions for Lars regarding this project? What I have are these young researchers or PhD students. They are distributed among these different partner institutes, and they are doing their work.
Yeah, so they are doing their work with the 10 beneficiaries, and then they are doing secondments, so shorter periods of research or study at some of the partner organizations.
Okay.
So they are distributed across Europe, but do joint training activities like Anna informed or told about earlier. We run some joint winter schools and training courses for some of the other projects within the BioRefine Cluster Europe.
There's one question in chat. How far have the students come in their work?
So they just started, most of them started and at the end of 2020. We were a bit delayed by COVID, but fortunately most of them have started. So they are in the first half year.
Okay, so it's still quite beginning.
Yes.
And the other question, are those training courses open also for other PhD students?
So the joint winter schools that we are running will generally be open for others. There are a few internal courses, but that's mostly, you can say, internal project things. But they will be announced through BioRefine Cluster Europe site.
Okay, thank you, Lars. I think that we have to go forward. And next presentation is Thilo Berendts from University of Utrecht. Please, floor is yours.
Yeah, good morning, everybody. My name is Thilo Berendts. I'm working at Utrecht University in the Netherlands, and I'm the coordinator of the Ptrap project. I hope you can all hear me. I cannot see myself. Kari?
Yes, we can hear you.
Okay. So similar to Fertiliser, Ptrap is the Horizon 2020 Marie Sklodowska-Curie Innovative Training Network. And our network has 11 PhD students working at 8 academic and private institutions all over Europe. And also we have a couple of partner organizations, for example, including Fertiliser, who has given the first presentation in this meeting. So the objective of Ptrap is to improve the quality of surface waters by reducing the phosphate loading. And in Ptrap, we target 2 types of systems, which are lakes and drained agricultural areas. So despite this variety of systems, all approaches and techniques we are developing and testing in Ptrap have in common that they rely on the strong natural connection between the biogeochemical cycles of iron and phosphate. So in view of the agricultural areas, we not only aim to capture the phosphate from drainage water, but also to convert the trapped phosphate into marketable fertilizers or soil conditioners. So in the first instance, the trapped phosphate will be in the form of iron oxides, which contain adsorbed or co-precipitated phosphate. In Ptrap, we are investigating the direct application of these phosphate-loaded iron oxides in agricultural soils, but also converting it into vivianite, which is an iron phosphate mineral, and we look also at its application in agriculture. So in view of this session, I would like to draw your attention to 2 of our PhD projects. So could you please switch the slide? So the first one is the project of Rochelle Sarakan-Lau. She's working at the University of KU Leuven in Belgium. And she is investigating phosphate release from different iron phases in soils. And she also looks at the phosphate uptake by crops from soils which have been amended with different phosphate-containing iron phases, and also obviously the related crop yield. So in this context, she's specifically focusing on the role of redox conditions in soils based on the hypothesis that phosphate can be better released from iron phases under reducing conditions. So the second PhD project, if you could move please to the next slide, is conducted by Tululupe Ayeyemi. She's working at the University at Seville in Spain. And she is investigating the application of vivianite to salts, although the focus of her project is not relying on the release of phosphorus, but on iron and the use of vivianite as a fertilizer to combat iron chlorosis in soils. So I hope with this brief introduction, I've been able to make you curious about the research of these PhD students. And if you want to learn more about the current state of the research, and if you have very specific questions, please visit our Ptrap website, and also don't hesitate to approach these PhD students and their supervisors if you want to learn more about this.
Thank you, Thilo. So, any questions?
Yes, if I may, this is Nathan de Geiter from Ghent University. Thilo, thank you for the very nice presentation. Yeah, I was wondering whether for the final solutions, the socioeconomics and who will that actually pay for such a solution, whether they are also being investigated.
Now, yeah, we have this as part of the training courses to also think about the social economical implications and implementations, but we don't have this as a research objective in itself. So eventually we skip this in our attempts to get the funding. So
okay, because I do think it's quite important, because even if you end up with a solution that works, yeah, if for example the revenue you get from developing the fertilizers to take into account the costs of recuperating the material, if they do not match up, then to reach to an actual application will be difficult.
Yeah, Nathan, I completely agree. And I just want to make a few comments on this. So so this project we are running is kind of in continuation of the Nuri Drain project. You might be familiar with this.
Yes.
And an important part here is actually the retention of phosphate from agricultural salts. And there's quite a high pressure to reduce the external loading of surface waters, which and then you have to think about the costs of trapping the phosphate, which would be required or which could be applied to do this. And this is a big problem in these more diffuse phosphorus sources, which are now becoming more and more the most dominant phosphorus flux into surface waters, at least in many European countries. So the later conversion is maybe then the second aspect, but I think in terms of economics, I guess the first, the driving force for implementing these technologies would have to come from reducing the phosphorus flux into surface waters. That's my expectation.
There's one more question regarding your presentation. That do you test any other quality aspects on the surface water?
Yeah, in terms of what we do in lake remediation and the treatment of lakes, for example, we look on various aspects in water quality, including the ecological implications. And regarding the export from the drainage systems, yeah, we also looked in the composition of the ditches and the export from these ditches, also for other elements, but this doesn't have a major, it's not a major research aspect here.
Okay, thank you very much. So we will proceed, and the next presentation is from Marcos Lator from Perseo Biotechnology, and he will present Waste to Bio project. Please go ahead.
Hello, can you hear me?
Yes.
Okay. Good morning. So first of all, thank you for the invitation to this meeting. My name is Marcos Latorre, and I'm a project manager in Perseo biotechnology company, and we were the coordinators of the Waste to Bio project. Firstly, just a quick presentation of our company. Perseo is an SME specialized in the development and engineering of biotechnological processes for organic waste valorization, and we perform the optimization of the process at lab scale and can demonstrate the processes in our semi-industrial plant, which is located in Alcudia, Spain, and we can treat more than 20 tons of organic waste per day. We have a patented process and can develop industrial projects with our more than 15 years of experience in the scaling up of biotechnological processes. Next slide, please. So the main objective of Waste to Bio project was to demonstrate a global process for the production of bioethanol as liquid biofuel from the organic fraction of municipal solid waste, biogas from the remaining recoverable organic fraction, and an organic fertilizer, just all integrated in an as an urban biorefinery. So the key of Waste to Bio project was to integrate both processes, the bioethanol production from municipal biowaste and the anaerobic digestion of the produced bioresidue, the byproduct from this process, which still contain valuable components to generate biogas and a digest state that could be used as an organic fertilizer. So the results of the project successfully demonstrated that this approach can reduce organic waste that is disposed and maximize its valorization into bioenergy and biofertilizer, boosting an alternative methodology and alternative circular model for the waste, for the municipal waste management. Next slide, please. Yeah, so and then in the project, the agronomic value of the Waste Bio digested was evaluated, and I'm not going to enter into detail in the measure parameters, just as usable as is in agriculture as organic fertilizer, micronutrients such as potassium, phosphorus, or calcium, and also micronutrients. There was no risk of pathogens and no heavy metals, and the digestate did not show any inhibitory effect in the phytotoxicity assays that we performed, but had a stimulant result on plant growth. So this digestate could be used as a nitrogen fertilizer, of course, along with irrigation with water, or subjected to a drying process if we want to store it and transport this fertilizer. And that's it. Thank you for your attention.
Thank you for the presentation. Is there any questions? There is some questions in chat. Do you use the digestate without any further treatment? Is it possible to use it as a direct application in your region?
I mean, it can be applied along with irrigation water, but of course, if you want to apply near very near your plant. If you want to transport and apply in another area, it is recommended a drying process, and then have a solid for the transport, because it contains a lot of water. So transport of water doesn't make sense if it's in a long distance.
And other question is that does the digestate from bioethanol byproducts have product status, or does it have a different status?
Pardon? Can
for example, if we consider this fertilizer product regulation, do you see that it might get this CE marked fertilizer status?
Yeah. I mean, if it when it comes from a biowaste that is separately collected, at least in Spanish regulation, I think also in Europe, it can be considered as a fertilizer. So, but this the origin of the feedstock must be a separated biowaste, urban biowaste.
Okay.
Or a separate collection, I mean.
And then there's was question regarding your slide that is these results on a dry matter basis results, or are they fresh weight result based on fresh weight on your last slide?
The last slide, you mean? Yeah, it contains.
Yeah, you have these physical chemical parameters. So
yeah.
Are the results presented here on a dry matter basis?
Yeah. I mean, the results are in a dry basis.
Okay. Okay, thank you very much.
Thank you
for your presentation, and we have to proceed. And the next presentation is Muhammad Musavi from Leibniz Institute for Farm Animal Biology. Please go ahead.
Hello. Can you hear me?
Yes, we can hear you.
Good. My name is Muhammad Musavi, and I'm a PhD student in Leibniz Institute for Farm Animal Biology. And this is the title of the study: Black soldier fly larvae reared on feed mixed with recycled sewage sludge accumulate calcium and phosphorus. One of the main problems of using the recycled phosphorus in animal diet is the problem of toxic compounds and heavy metals in the recycled products. Black soldier fly larvae has been suggested as an alternative source of protein for broilers, and they are able to change some of the minerals in their body in response to the amount of the minerals in their diet. So in this study, we investigate whether the black soldier fly larvae can be enriched with phosphorus and other minerals based on the sewage sludge recycled products. So for this study, we had 4 dietary groups to feed the black soldier fly larvae. In the positive control diet, all of the larvae raised on the chicken feed, and in addition, we had 3 Gainesville diets. In one of the Gainesville diets, we didn't use any recyclate, but also we had 2 different recyclates, and we used 4% from each one in the Gainesville diets. And the difference between these 2 recyclate, SSP and carbonizate, was based on the different recycling technologies and also different mineral content. So as you can see, SSP had a higher calcium and phosphorus content compared to the carbonizate, but lower in magnesium. Our results showed that the higher calcium and phosphorus content of the SSP recyclate resulted in a higher calcium and phosphorus content of the larvae. However, the body, as compared to the other groups, however, the body weight of the SSP group and also crude fat and crude protein content of the larvae which raised on the diet, including the SSP recyclate, was lower compared to the other Gainesville diets. So at the end, we concluded that the black soldier fly larvae can be enriched with calcium and phosphorus, and it confirms our hypothesis that the black soldier fly larvae can accumulate minerals in their body in response to the amount of the minerals in their diet. And also, we concluded that the higher body weight of the larvae caused higher crude fat but lower crude protein, and this should be taken into the account when we want to produce the larvae for feeding to the animal diets. Thank you so much for your attention.
Thank you for the presentation. This was indeed different approach for nutrient recycling. So is there any questions regarding this presentation? I was just considering that is there any like legal restrictions for using this type of ingredients for feeding chickens and so on?
I think still in European countries it's not allowed to use them in the animal diets, but I think in some of the countries, like I think in some of the states in the US, it's allowed to include them in the broiler diets. But we hope that in the next years, also in the European countries, it would be allowed to include them in the broiler diets.
Thank you very much. Is there any other question? If not, we can proceed to next presentation. It's given by Dejene Etisha from Yara International.
Thank you.
Yes.
Could you give me a signal if you hear me?
Yes, we can hear you.
Great. Thank you very much for invitation. My name is Dejene Etisha from Yara Research Center Honeycomb. Yara is, maybe as many of you know, it's a fertilizer company, rather a crop nutrition company. And I am working in agronomic research center and myself as agronomist. Organic waste materials are an important source of nutrient elements that can be reused in agriculture. And so recovering essential nutrients from organic waste materials and recycling it in agriculture can contribute to better use of or sustainable use of resources. And it is also more environmentally friendly. When we say about sustainable use of resources, particularly regarding nutrients, phosphorus is the main focus because it is a scarce resource in the world. So if we can recycle and use it in agriculture, that is a great contribution of sustainability. There are different waste materials, waste streams that can offer possibility of nutrient recycling. These are mainly wastewater treatment plants or animal production installations where animal manure can be obtained, digested from biogas plants, or waste from food processing industry. So Yara evaluates opportunities related to nutrient recyclates with the aim of using these recyclates in agriculture. And we have identified three different possibilities or pathways of using them. The first one is to use recyclates directly in agriculture as fertilizer, as a direct fertilizer, which usually not so easy. The second possibility is to use the recyclates as a raw material in processing or fertilizer production factories, depending on the product characteristics. And the third possible use is to use it in a small local industrial loop where there is demand for the product in the locality. As you know, usually the place where the recyclates are produced is far away from the place where the factories or fertilizer factories are located, or from the place where the nutrients are used in agriculture. So the recyclates must be transported long distances, and for this purpose, it has to have high nutrient content. Otherwise, it does not pay off to transport long distances if the nutrient content is low. In some cases, the recyclates must be reprocessed if it is not directly used in fertilizer production factory. So intermediate products can be used and transported to be further processed in a high value fertilizer. Under special circumstances, it may also be necessary to install local fertilizer production facility close to where the recyclates are produced. In that case, it is possible to reduce the transportation cost, particularly for bulky materials which contain valuable nutrients, but from the weight point of view that are very bulky. A specific example is organic fertilizer or organomineral fertilizer, and in fact this depends on the local demand or local market demand of such products. We are looking at we are working on different aspects, evaluating these products for use in industry, quality criteria, and also agronomic efficiency. And yeah, we are having collaboration partners where we work with resource owners like wastewater treatment, incineration plants, research institutions, because only collaboration can bring the successful implementation of this recycling activity in agriculture. So thank you very much for your attention, and if you have questions, please you can ask.
Thank you, Dejene. We have time for one quick question. I could make a one that do you see that these recycled materials they can replace mineral fertilizers in a bigger scale in the future?
Replacing, I would say, may not be 100% replacement, but there could be a large contribution from recycled nutrients to be complementary and used side by side with mineral fertilizer. This is very much depend on the location. For example, if you consider the phosphorus fertilizer or phosphorus from recycled materials, it can, let's say, cover the largest percentage of demand in Europe, but not in other parts of the world, because Europe is importing animal feed, and it is concentrated here. So it depends on the location.
Okay, thank you very much from your presentation, and we proceed, and the next presenter comes from Yu Hu from IPK Leibniz Institute.
Hello,
floor is yours.
Can you hear me well?
Yes.
Okay, nice. So hello everyone, my name is Yue Hu, and I'm from Leibniz Institute of Plant Genetics and Crop Plant Research. I'm very glad to have this opportunity to present to you my project. The topic of my project is phosphorus utilization capacity of forage legumes from recycling products. which aims to access the ability of alpha and red clover to utilize the P from recycling products, and also investigate the intra and interspecific variation of P efficiency in both species. This project consists of 3 major experiments. First, a preliminary experiment to select suitable accessions of alfalfa and red clover based on their biological status, plant P content, maturity group, etc. And the selected accessions will be cultivated in a pot experiment and also a field trial. In the pot experiment, 5 treatments were compared with 4 replications, and 3 of them, sewage sludge ash, bio-waste compost, and struvite are P recycling products, and 5 accessions of each species were tested. For the field trial, which was based on a long-term field experiment at the University of Rostock since 1998, 6 treatments, including 3 P recycling products, the biomass ash, the manure, and bio-waste compost, were compared with 4 replications, and 8 accessions of each species were involved. Based on our harvest last year, we have found a significant intra and interspecific difference of P uptake in alfalfa and also red clover. Compared with no P, a significant higher increase of P uptake was also found in treatments with organic recycling products. And this year, we will continue the field trial and also repeat the pot experiment to verify the result from last year. That is the brief introduction of my project. Thank you very much.
Thank you very much for keeping on schedule. So, any questions?
Okay, I'm reading.
Is there in chat any questions? Yeah. There's a question from Anna. Why do you want to check specifically the P uptake from recycled P products in these species?
Yeah, first, so we don't have so much research on this area, so it's kind of like a blank area. I think it's good to have research on this, and also the phosphorus. In our group, in this University of Rostock, here where I'm working, it's the topic. It's this phosphorus in a long-term field experiment. So it's a combination of this long-term experiment and also with this forage legumes. So yeah.
I would like to ask a question regarding these results. That what do you think that is the reason that if you have a compost or then compost plus TSP, there is no increase in P uptake? So
yeah, I think this double treatment, this compost plus TSP, yes, we want to make sure if there is also a quantitative influence of this, but it seems that maybe that is also already saturated, so the plant cannot utilize more of the phosphorus in the soil from the fertilizer.
Yes, that's what I was thinking as well. So
yeah.
So I can understand that it's very difficult to get such soil that is phosphorus deficient to have actual yield responses. Any other questions? If not, I'll thank you, and we will go to the last presenter, Natalia Herrero from Biomassa Peninsular will present the Urbiofin project. Please, floor is yours.
Good morning, everyone. Can you hear me?
Yes.
Okay. My name is Natalia Herrero. I am project technician in Biomassa Peninsular, and I would like to briefly summarize the Urbiofin project. Urbiofin is an Horizon 2020 project, which is coordinated by Perseo Biotech. The consortium is composed by 16 partners, and the project started in 2017 and it will finish in 2022. The aim of our project is to demonstrate the viability, economic and environmental viability of an integrated biorefinery to convert 10 tons per day of organic fraction of municipal solid waste into new bio-based products of high added value. Next slide, please. And as you can see in this diagram, our project is divided in 3 different modules. The first module, the organic fraction of municipal solid waste, will be converted into bioethanol to then produce bioethylene using the technology developed by Perseo Biotech. The pilot plant is located in Valencia, and the bioethylene will be validated as ripening for fruits. In the second module, it will be performed a two-step digestion, anaerobic digestion in Zaragoza at Urbacer facilities to produce in the first step volatile fatty acids that will be then converted into PHA and validated producing cosmetic pots, garbage bags, and also mulching films. The digested coming out from the second part of the digestion will be then used in the third module to develop organomineral fertilizers. And additionally, in this module, microalgae will be cultivated as upgrading biogas bioreactor. And microalgae will be then valorized to produce amino acid-rich biostimulants after an hydrolysis, enzymatic hydrolysis, and a concentration step. Next slide, please. In particular, our activities, Biomasa Peninsular activities, are focused in the production and validation of organomineral fertilizers and also biostimulants. We are working together with other partners of the consortium. These organomineral fertilizers will be formulated using digestate together with mineral additives to better adjust the NPK formula to the crop's requirements. We will also study the legal conformity of the granules produced under the fertilizer product regulation. And these granules will be produced in a spouted bed dryer. After the granulation and formulation, the performance of both fertilizing products will be validated in open field conditions in agronomic assessment in different crops and locations. And I would like to conclude mentioning that our activities has been mainly focused in the construction of the pilot plant, so we have no results in these moments. We'll expect to have results at the end of the present year and in 2022. And this is the summary of our project. Thank you very much.
Thank you, Natalia. Is there questions for this presentation? I think that at this stage we can, because there has been quite a lot of questions in chat and we haven't able to go through all of them. So if you want to raise some questions that we haven't gone through during this session, you can open your mic and ask questions directly from the presenters.
I think we have a couple of questions for this last presentation right now in the chat.
Okay. Okay, so there's a, do you have some data about the nutrient content of this organomineral fertilizer?
We performed some preliminary trials, but as I mentioned before, we are focused in the study to reach the steady state conditions of the digester. So our results are very preliminary now.
And there's other questions related to this same issue, that which is the average composition of the organomineral fertilizer you are producing?
Yeah, as mentioned before, we performed some granules. We obtained some granules, but the composition is not optimized. So we will continue developing and optimizing the formulation when the digested and when the digester reaches the steady state conditions.
So have you done this microbiological analysis and these like organic contaminants, whether those are included in your fertilizers?
Yes. We started doing some characterization of the digestate and also of the granules obtained to determine if the presence of contaminants, pathogens, and also heavy metals, but the results are preliminary, so we are not comparable.
Okay, thank you very much. Does anyone wants to raise some questions for other presenters before we go to lunch break? You still have 4 minutes time to make some questions.
Can I just ask the person presenting about clover and alfalfa, what kind of plant characteristics are you measuring to explain the differences in phosphorus uptake?
Sorry, could you repeat your question? I didn't hear well.
What are you measuring to explain the differences between you compare quite many different varieties of the alfalfa? So what are you measuring something in these plants to be able to explain the differences in phosphorus uptake and phosphorus?
So when we have this difference of the P uptake, I think the phosphatase, the enzyme activity, we have this dehydrogenase and alkaline and acid phosphatase. We also measure this. We want to have if there is difference of the enzyme activity and also the root morphology, if that's a grading factor for this difference.
Okay, any other questions?
Yes, I would like to ask to this last presentation that we have heard in Spain, like if the input, the feedstock is bio waste from separate collection, or if there are also mixed waste.
Natalia, are you still online? Did you hear the question?
Sorry, can you hear me?
Yes, now we can hear you.
I didn't hear the question. Can you repeat, please?
Yes, I was asking if in the feedstock, in the process, you use only bio waste or also mixed waste.
Is the separated fraction of organic, the organic fraction of municipal solid waste, not mixed.
Okay. At this point, I want to thank you all for active joining to this session, and I think that we will close this session now. And if I'm correct, Maurizio, correct if I'm wrong, that we will have a lunch break next.
Yes, now we have a break and the closing session will start at 2 p.m.
Okay, thank you.